All right, hey everyone, welcome to the final week of distance learning. We made it. It's been a long haul, but I want to say I'm so proud of all of you for doing all the work, for catching up, for staying on top of things, and just for being a part of this class. I know it hasn't been easy on any of you, but I appreciate the work that you guys are doing, and I hope you appreciate this as well, okay? So the last lesson today that we're talking about, guys, is on titrations. Now, a titration is when we take an acid and a base and we react them, but we do it in a controlled environment. What I mean by controlled environment is I don't just take, two beakers and dump them together. I have one sample that's in, something like this, like a flask, and I'm dripping the other solution into it with a valve that I control, okay? So whenever you see a question that says titration, that is what it means, okay? So the example that we're gonna be looking at today is a standardization. Now, whenever a question asks you to standardize something, it means determine a concentration. So this question, example 1, says find the molar concentration, moles per liter, of sodium carbonate, of sodium hydroxide. That's what it says. So I'll reread. Find the molar concentration of sodium hydroxide solution given the following, okay? It's a titration of 25 milliliters of sodium hydroxide with 0.352 hydrochloric acid, okay? And they give us some information. So the first thing that I'm going to do is I'm just going to kind of rewrite this table, okay? So I stands for initial, F stands for final, E stands for equivalence point, okay? And then we've got trial number, we've got trial 1, trial 2, trial 3, and trial 4, okay? Okay, now the initial here says 0.0, then it says 15.9, and I'll explain what these numbers mean, guys. 31.2, 1.4, finals, 16.6, 46.4, 31.2, and 15.9. Okay, so I'm going to explain what each of these numbers mean, okay? So imagine that I have a burette, a long skinny tube, and it is completely filled, okay? When it is completely filled to the very, very top, we say that it has a starting volume of 0, okay? What this means is if I started at 0 and I ended at 15.9, what that means, guys, is I added the difference. I added 15.9 milliliters, because everything's in milliliters, to the solution, okay? The E stands for equivalence point. Equivalence point, okay? Now, the equivalence point is how much acid we had to add to equal the amount of base. That's what it means. So in this example, I added 15.9 milliliters to complete my reaction. In the second example, what I'm going to do is I'm going to take my final 31.2 and I'm going to subtract what I started at 15.9 and I get 15.3. Okay. In the next example, I'm going to take 46.4 and subtract 31.2 and I get 15.2. And in the last example, if I do that math in my head, I should get 15.2. Okay, so I have 4 different trials. I did this experiment, guys, 1, 2, 3, 4 times, and I ended up with 4 different equivalence points, okay? Now, here's the thing. When I want to calculate my equivalence point, I don't want to use every single number here. I only want to take the numbers that are the closest, okay? So in order for me to figure out the volume, my equivalence point, the volume of my equivalence point, okay, because I did different trials, I need to find the average. Now the average is going to consist of whichever of these are close, okay? How close? Good question. So the volumes that I want to choose have to be plus or minus within 0.2 milliliters, okay? So let's look. Are these two volumes within 0.2? Yeah, they're the same. So they're both going to go in. Is 15.3 within 0.2? Yeah. Is 15.9? No. 15.9 is too big, so we're going to leave it out. Again, I only want to choose the 3 closest volumes, okay? And the reason I do that is I can't just pick one of these. I want to have a more accurate answer, so I have to choose a couple of them and find the average. So what I'm going to do to find the average volume is I'm going to add them. So in this case, it's my second volume plus my third volume plus my fourth volume. We divide by 3. So I'm going to get 15.3 milliliters plus 15.2 milliliters plus 15.2 milliliters divided by 3. So my equivalence point on average is 15.23 ... repeated. Okay, milliliters. Don't round that number. Okay, so what does this number mean, guys? So this number is the equivalence point. The equivalence point is the volume that we added to the reaction to reach the point where all the acid and all the base have reacted. This means the solution is neutral, okay? So now what I have to do is I have to answer the question. The question said, find the concentration of sodium hydroxide. Okay, well, in order to figure out any information, I'm going to need a balanced chemical equation because I'm dealing with chemicals. So that balanced chemical equation, guys, is, let's write it down here. NaOH, sodium hydroxide, and hydrochloric acid, okay, acid and a base. Now, the products of every acid-base reaction are salt and water, okay? Salt and water. So how do I get water? Well, water is H2O. Salt, another name for salt, guys, is just an ionic compound. Ionic compound is a metal, Na, and a nonmetal, Cl. And we're going to put aqueous because it dissolved in water, okay? This is my balanced chemical equation. Now, it's asking me for the concentration of NaOH, okay? And I know that concentration is moles over volume. If I look at my question, does it give me a volume of NaOH? Yes, it does. What's that volume? The volume is 25.0 milliliters. Okay, do we like milliliters? No. So we're going to divide that by 1,000 and we're going to get 0.025 liters. So if I think about finding concentration, I'm going to divide the moles by 0.025 liters. Okay, well now I need the moles. Didn't tell me what the moles of NaOH were. However, did it give me some information about HCl? Okay, it gave me the concentration of HCl, 0.352 moles per liter. Did it give me the volume? Yeah, I remember that I am adding HCl out of the burette. That means that I am adding this much HCl. I already have the volume of NaOH. This means that the equivalence point is the volume of HCl because I'm adding it, divided into liters. So what I can do now, guys, is I can find the moles. And guess what? This problem now becomes a molar coaster problem. Okay. Sorry, it's getting a little small there. Okay. So I get 0.005362. Okay. Now, to go from here to here, I have to divide by 1 and multiply by 1 so it stays the same. I know it's getting a bit small. I apologize, everyone. Okay, but it's going to come together. So I'm going to move over here now, just so you guys can see. So concentration, I'm going to take that mole number, which is right here, and I'm going to divide by 25 liters, or milliliters, so 0.025 liters, and I'm going to get 0.2144 ... moles per liter. I got, looks like 3 sig digs. We'll go 2 sig digs because of the 0.0 milliliters. So 0.21 moles per liter is my final answer. And that, guys, is the concentration of NaOH. So what are some things that we need to remember as we solve these questions? Okay. Question said, find the concentration of something. Okay, that means we need moles and volume. How do I get moles? Molar coaster. If I need molar coaster, I need a balanced reaction. Okay. This one was easy because it was just ones everywhere. Sometimes it could be different. How did I get this volume up here? So whenever you see a table that has that bottom row, you're going to need to subtract the numbers to find the volumes that you added. Again, these are not volumes that you added. The difference is how much you actually added out of the burette. Okay. Once the mole, at that point, I have the same amount of acid and base, so the moles should be equal in theory. Okay. And then I can find my equivalence point by calculating the average, because again, we want the best representation, and that becomes the volume that you add. Okay. So on your guys' assignment, you're going to have a couple questions like this. Okay. The process is going to be the same. You're just going to have some different reactions. All right. And this is something that we're going to need to know for next year.